In this example, on the same axis, sketch the graphs of y equals 3 to the x, y equal 2 to the x, and y equal 1.5 to the x. So first, for us to sketch these graphs, we take the values of x to be -3, -2, -1, 0, 1, 2, and 3. And then we create our table for y equal 3 to the x, and also y equal 2 to the x, and also y equal 1.5 to the x. So we plot these values, and that will give us the graph in the form shown. So we can see that all three graphs are for all three graphs, y is equal to 1, which is this point here, and we can see, and this is when x is equal to 0. Now that tells us that when x is smaller than 0, then 3 to the x is smaller than 2 to the x, and it's smaller than 1.5 to the x. Okay, so you can see that it is getting smaller as the value of x gets smaller. The value of y to the x 1.5x is also reduces. Now also when x increases, then we will see above 0, then we will see 3 to x bigger than 2 to the x, and also bigger than 1.5 to the x. And this is how we prove that where they intersect, and also as the values of x increase or decrease, how would these graphs behave. For part B, it's a similar scenario. So we will create the graph where we take the x values as -3, so this is for part B, -2, -1, 0, 1, 2, and 3, and then we plot half to the x. So now will give us the graph being in the form shown. This graph, so the graph of y equal half to the x is equivalent, is also, it can be considered as a reflection of reflection in there is a reflection in the graph in the y-axis of the graph y equal 2 to the x. Now how do we prove that? The way we can do that is we can represent half can be represented in the form of 2 to the power of -1, and if we are subbing that in the form of x, because we have 2 to the -1 to the x, because this is the original formula that we have, then that can be represented in the form of 2 to the power of -x, and we are explaining that we are taking the reflection, which is the opposite of this graph, and we can see that they intersect at the point here, and that will prove to us that we can use the reflection also as the opposite of the graph half to the power of x. In this example, we need to sketch the graph of y equal half to the power of x -3. Now we need to give the coordinates of the point where the graph crosses the y-axis. So if f of x is equal half x, then the y is equivalent to f of x -3, so that the graph is translation of the graph y equal half, and where it is x, by the vector 3 and 0, where represents the xy coordinate. Now the graph crosses the y-axis when x is equal to 0. So that tells us we take y as half, and when we have x at 0, that will give us 0 minus 3. So that will give us half to the power of minus 3, which will give us, in this scenario, 8. Now the graph, that will tell us that the graph crosses the y-axis at 0 in terms of x and 8 in terms of the y coordinate, and this is how the graph would look like, and this will prove to us that when x is 0, it crosses the y-axis at 8, and this is our answer for this expression. In this example, we asked to draw an accurate graph of y equal 1.7 to the power of x for the range of minus 4 being bigger than or equal to x and x being bigger than or equal to 4. And also for the second part, we also need to solve the equation. So for part A, we need to plot the graph. So we take x from minus 4. So we have y.7 power of x. So we have minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. And we find the value of x. So we plot the values of x into it, and that will give us finding the graph, which will be represented in the form shown. Now for part B, we take 1.7 to the power of x equal 4. So the 1.7, it can be represented in the form of ln, so that will be x ln 1.7 equal ln 4. So in this scenario, x will be ln 1.7 over ln of 4, which will give us approximately 2.6 as the answer for x. In this example, we need to draw a graph for the expression y equals 0.6 to the power of x for the range of minus 4 bigger than or equal x and bigger than or equal 4. So first, for part A, we have x equal minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4, and y equals 0.6 to the power of x. And the graph that we plot, it will look in the form shown. So for us to solve for part B, we need to solve the expression in the form of 0.6 to the power of x equal 2. So we can multiply both sides by a ln, so that will give us x ln 0.6 equal ln of 2. So x will give us ln of 2 over ln of 0.6. So that will give us approximately minus 1.4 as the answer for this question. In this example, we need to sketch the graph of y equal 1 to the x. So first we take values of x. So we can do that, for instance, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. And then we plot the values of 1 to the x. So that can be shown in the graph shown here, and you can see the values will be created in the form of a straight line across and will cross at the point of 1, and this will be our answer for this question. In this example, for each of these statements, decide whether it is true or false, justifying your answer of offering a counter example. The graph of y equal a to the x passes through 0 and 1 for all positive real numbers. So for part A, this is true because when x is 0, then you would have y being in this scenario and a to the 0. It will give us 1. So when a is positive, so when a is positive, then it will give us the values of a to 0 equal 1 when a is positive, and this will be our answer for part A. For part B, the function of fx equal a to the x is always an increasing function for a smaller than 0. In this scenario, this is a false statement, and for example, when a is equal to a half, then the function f of x equal a to the x is not an increasing function, an increasing function. For part C, we need to graph of y equal the graph of y to the ax, where a is a positive real number, never crosses the x-axis. This is true because when a is positive, a to the x bigger than 0, all value for all values of x, for all values of x, and this will be our answer for part C.